This debate, being called parallel light, has some mile-wide goalposts. So I'm going to go ahead and score a quick goal, and then we can move on and narrow things down. Mr. Sensible, hopefully you'll agree with me that this is not what globalists mean when they say that the light from the sun is parallel.
Okay, we got the sun, which is a sphere, a big sphere. I don't think there's any doubt about that. I hope there's no doubt about that. Now, the rays of light from the sun go out in all directions, 360 degrees, all around the sphere. Basically, it shines equally from all directions. So if we had a close-up on one portion of the sun, the light rays are actually going out at each and every direction from every point in the sun. When we talk about the sun's rays coming towards the Earth, that doesn't mean that rays aren't flinging off from the same point all over the place. So any individual point on the sun will be shining out in every direction. So this whole area, even if that was the only point of the sun that was lit, this whole area you could see it from, because light photons are travelling outwards in every single possible direction. So if we took a look at the sun and the Earth, this is not to scale. None of these drawings are to scale. They can't be. We've got rays of light flying off the back side of the sun, downwards, upwards, every which way but loose. The only ones we see, though, are the ones that are roughly travelling along in this direction until they hit the Earth. So that long cone shape or triangle shape, that's the path of light that hits us. Light is going everywhere else as well, but we don't see it. So from there, we can see the top of the sun, we can see the bottom of the sun. We see the whole sun.
Goal! Fantastic. Common ground. No contest.
We're talking about the light that we see. The light that reaches the Earth. Because it's a three-dimensional spherical light source, light goes out equally in all directions. But the only light we see is the light which hits our eyes, the light which reaches us. The light which reaches us is all but parallel.
Okay. Just the light that reaches the Earth. Let's take a look at NASA's claim on that matter. A quick search takes me to nasa.gov, and they're talking about crepuscular sun rays. When observed from the ground, crepuscular rays appear to radiate outwards from the light source due to the effects of distance and perspective. However, the rays are actually parallel. The astronaut photograph from the International Space Station provides an unusual viewing perspective from above the rays and a clear illustration of their parallel nature. Okay, let's go take a closer look at that image that they're talking about here. They are claiming that was taken from the ISS? More like a weather balloon or a high-altitude plane. Unless it was fabricated altogether, and I wouldn't put it past them. More importantly, though, they're claiming this is an example of parallel light rays. So let's measure this out. Here's a line. Now let's draw an equally sized line. Uh-oh! What's going on there? If they are parallel, they can neither converge nor diverge. With that being so, those shadows can't get bigger or smaller. They have to stay the same size. And in case you were confused, NASA has provided a hyperlink in the word crepuscular rays to explain things further. Crepuscular rays, also known as sun rays, are a mesmerizing atmospheric optics phenomenon that captivates the imagination. These ethereal beams of light, streaming through gaps in clouds, create a breathtaking display of nature's beauty. Oh my word, they just used the word ethereal. When NASA referred to them, they gave them subject matter expert authority. And they are acknowledging the luminiferous ether, which is a really big deal, but that's not really a matter of this debate, but it's worth remembering for the future. The luminiferous ether. The parallel columns of sunlit air, separated by darker cloud-shadowed regions, give the impression of diverging rays. Diverging rays are rays that get farther apart. These rays appear to be coming closer together. These show apparent converging rays. Much like parallel furrows of freshly plowed fields, or a road that appears to narrow with distance. And if we scroll down here, we can find an example of what they're talking about. Here they're talking about parallel furrows again. And what image are they providing to illustrate that? Those are their parallel furrows? I know what one-point perspective is, and the merging of these rows is not one-point perspective. Those rows are actually merging together. And if we look over here, those rows are actually diverging. These rows are not even straight. That's not exactly your best example of parallel, NASA. I would have gone with railroad tracks. These parallel rails appear to get closer together out in the distance and farther apart as they get closer and closer to you. So what's going on here? Well, if this end of the shadow is farther away from you than this end of the shadow, then you can make an argument saying that it's the railroad track effect of one-point perspective.
I did wonder if you were going to make a comment about something like this, Kyle. This picture, this sort of thing. Does this have any bearing on your discussion?
There is quite a bit of one-point perspective going on here, like the railroad tracks. I fully acknowledge that. However, there is some evidence of non-parallel light going on here as well, if you take a close look at the edge of the shadows. They're fuzzy. It's not a clear, crisp shadow. The fuzziness of the shadow is because of penumbra. It happens when light hits an object from two or more different directions. NASA loves to claim that the light from the sun is parallel until a solar eclipse comes along and, now it's no longer parallel. This alone should resolve the rest of our debate concerning the light from the sun that reaches the Earth not being parallel. Do you agree that that penumbra exists because the light is not perfectly parallel?
Okay, I will come back to penumbra in a moment because I have something to say about penumbras, okay, if I may.
Okay, I acknowledge your choice not to answer the question.
Okay, so you're saying not parallel because of the penumbra. Would you make any claims with regard to those visible rays of light?
I just pointed out the penumbra.
Just the penumbra. Okay. Well, Carl, I have to say I'm glad. I was fearful that you would say the same as Rachie and say, yeah. Those rays of light are diverging around that from that center point. So I'm glad.
This is a two-dimensional plane. They would, but if
but we're talking about an image of a three-dimensional.
That's not
view.
my argument. And so,
that's why I'm glad. That's fine. That is fine. I won't hold that against you or hold. I won't hold that against you. I'm glad that that's not an argument you're making, because the next thing I was going to show was that because those rails are vertically parallel to each other, but the shadows apparently are diverging. They're not really. It just depends on your view. As you said, it's perspective, but that's not the argument you're making. So that is.
I like this example of the penumbra again on the shadows. It's a very clear, obvious statement or observation that says the light from the sun is not parallel.
Sorry, 1 second. I just want to check something. Okay. Right. Well, like I said, Carl, I'm genuinely glad about that. So, okay, let's go to umbra and penumbra, because I did a video about that some time ago.
Yes, I'm aware of that.
Yeah. Oh, so you've seen this video before?
Yes, I have.
Okay, because that was, what was the guy's name? Gosh, I can't think of his name now. He was saying that a penumbra couldn't be larger than the original object. And for those who haven't seen this before, I'll just sort of scoot through it. So I had a sheet of paper with a cardboard disc, which I I drew round a cardboard disc, basically, left a circle. I then moved... Actually, let's just play it. I moved the disc further and further away, casting a shadow as accurately as I could in the middle of the circle. I then took several screenshots of the video, and with editing, I took out... Sorry, I'm just trying to find the exact point. There we go. I took out the white of the page, so all you would see is everything that was left. I want to find the exact point. That was next image. Right, so this was the final paused image. Took out the white, and then when I deleted it, I'm going to go right to the end. I'm sure it shows. Oh, that's it, actually. Yes, I've deleted the white, leaving the black, showing the penumbra larger than the drawn circle. So I had that ready. So I suppose in a way it's good that you brought up penumbras. Excuse me. Yes, you get a penumbra because of the convergence and divergence of rays. So we can agree on that, Kyle.
Bam! Thank you, Mr. Sensible. The light from the sun that reaches us is not parallel. Common ground.
And you're correct. If you look at, if I go right in, oh, this is funny. It doesn't seem. Oh, there. The shadow looks pretty sharp. I mean, it's not perfectly sharp, but pretty sharp. But as you get further away, it blurs as the penumbra gets more and more noticeable, and the umbra, the dark bit, appears to get smaller. So I guess there's no disagreements there then, Carl.
So yeah, you're telling me that you agree with me that the existence of penumbra demonstrates the fact that the light from the sun is not parallel, correct?
Well, the light from the sun is within half a degree. That's the most divergent, convergent it can be, because that's light from the top and the bottom of the sun.
Well, it's important to remember that this is a small object that we are observing the penumbra on. Though the sun isn't a point source of light, let's just observe the hands of a clock for a moment. The closer these hands get together, the closer they get to becoming parallel. Now this is called a pinhole projector. It's about as narrow as it gets when it comes to viewing the sun. People use them for viewing solar eclipses. Things like this wouldn't work if the light from the sun was parallel. And yeah, you could say that's just a little bit of non-parallel light, but keep in mind, the hands on that clock are super close together, just being a pinprick apart. When we start talking about Eratosthenes, however, we're not talking about that narrow pinprick viewing angle. The distance between Alexandria and Syene is a lot bigger than that.
The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths.
Just looking at that diagram here, that is a lot of penumbra. A lot of non-parallel light. So, do you agree with me that almost parallel light should produce next to non-existent umbra and penumbra?
The closer it is to completely parallel all over, then you would get no umbra penumbra. If you had a light source the exact same size as the blocking object, then its shadow would trail behind it in a cylinder, wouldn't it? If the light is bigger, yes, that shadow will get smaller in a cone. If the light source is smaller than the blocking object, the shadow will get larger in a cone.
So the closer we get to being perfectly parallel, the less, the smaller that penumbra is going to be. And so
yes,
if it's perfectly parallel, it's non-existent. So it sounds like we agree. We agree on that. We should, therefore, have no problem tossing out this whole Eratosthenes thing then. It's garbage. Now I'm going to date myself here for a moment. I graduated high school in 2006. This is my high school earth science textbook. And it taught me about Eratosthenes, and it made this big claim to the parallel light. This was supposed to be proof that the Earth was a globe. There's a digital version of this book that is open to the public and available for free at archive.org. One of the cool things about digital copies of the book is this search feature, where you can just type in Eratosthenes, and then afterwards it'll point out every single time in the book that the name Eratosthenes is mentioned. And there you go. There's our page. Now here's where things get interesting. That book was published in 2002. And as it goes with science books, they continually get updated. So let's go take a look at a more current version of that book. This book is Earth Science, which was made by the same publisher in 2010. Now let's go search for Eratosthenes in here. No matches found. He was utterly removed from the book, and for good reason. And in case you're wondering, here's a side-by-side comparison between the two books. This one's the older, modern Earth Science, which begins by saying, "What is Earth Science? Since the beginning of human history, people have observed the world around them and wondered about the forces that shape the world." And then as we scroll down, we'll see this reference to the Mayans. Okay, let's go take a look at the other book. Here's the updated Earth Science, which begins by asking, what is Earth Science? For thousands of years, people have looked at the world around them and wondered what forces shaped it. And as we go a little farther, there's a reference to the Mayans. Feel free to check out both books for yourself and witness that Eratosthenes has been tossed. His entire argument depended on the light from the sun being parallel, when clearly it is not.
Well, the other thing you had was light dims over distance, sunset,
Yes.
And you're saying about the sunset dimming.
Uh-huh.
Do you want to just expand on that a little? Just a little to explain your position and or what you're saying?
Sure. I really enjoy this candle observation when looking at the light as it travels across the wall. Immediately around the candle, that light is really bright, but the farther away you get from the candle, the dimmer that light on the wall gets. That is because the light from the candle is not parallel. It spreads out and becomes less dense over distance. The exact same thing can be observed when you look at sunlight.
When you said sunset dims, that's because as it's going down, I mean, the sun is not changing its brightness whatsoever. But what's happening is the light is getting more scattered as it's travelling through more of the atmosphere, so less of the actual photons are hitting your little eyeballs.
Okay, and so scattered light is not parallel. I hope we can agree.
Yeah, I mean, it's bouncing around all over the place by then. Okay, right. Well, I'm going to thank you, Kyle, for joining us tonight. We've been going for about 2 hours 20. It's been
very civil, so I appreciate that.
Oh, I think it always will, Kyle. I mean, not being funny, I'm going to disagree with you. I'm going to think that some things you say are wrong or silly, but I see no reason not to be civil, as you've not been not civil with me. So, any last words, Kyle?
Am I in trouble here?
No. And yes, any last words? I need a black cap on. You shall be hung by the neck until dead for your flat Earth beliefs. Hey, it's not a bad idea, though, is it? No. Any final words before I let you go? I suppose.
Thanks for having me, and yeah, hear me out. So, look forward to next time, as always.
Yeah. Cool. All right. Well, thank you very much, Kyle. You take care, and I hope you and your family all stay well.
This message has been brought to you by the Flat Earth Institute of Science, with a shout out to our Flat Earth friends at jdecals.com.
Hey Karen, being the current queen of Flat Earth, it must be hard to find Flat Earth friends. Do you know an easy way to find cool people like yourself and Solid info about our stationary horizontal level plane.
Why, yes, that would be the Flat Earth, Sun, Moon, and Zodiac Clock app.
Yeah, it's the perfect gift for friends, family, and complete strangers. Watch the featured video every day for 2 weeks and see what happens. It'll be the best $2.99 you've ever spent.
And never forget, according to Eratosthenes, this table is a ball.
Thank you very much, all. Take care. Good night. Stay sensible.
Mr. Sensible, Mr. Sensible, bring me some cheese, and get me only the best if you please, best if you please. Here are some flowers, let me display them. Hey, Dr. Warner, you have Arnold slay them. Mr. Sensible, Mr. Sensible, you are a man. Every subscriber is a faithful fan. Bring your logic and your cheese, Mr. Sensible.